Hi friends, welcome to this live session. So can you hear me? Welcome everyone. And in this live session, we'll be doing a chemistry revision for class 10 CBSE. So can everyone hear me loud and clear? Yeah, hi, I can see Goranji is there, M2 Gaming, Keshav Jindal, Kushwant Kumar, hi. Mohan Das, hello. Hi, Monu Rajput. Hi, Naveen Kumar, hello. Okay, so great. You guys can hear me. And I know a lot of you have your exam coming up tomorrow. So I'll like to really get started quickly here. And this is going to be a power pack session where we are going to be doing some important chemistry questions, right? And I've selected questions from different topics. So this will be a great revision before your exams. Hello, Vishnu Mehrotra is here. Hello, Kush. Amrut Patel, hi Renu. And I'll try to finish this session in 40 minutes since I know many of you have your science exam tomorrow. So wishing you all the best in advance for your exam. Go give it your best shot and I'm sure you'll do well in the exam. Hello, hi everyone. So the goal again of this session is to go over some really important questions for chemistry, right? And we'll be focusing on, we'll be looking at different topics and I'll show you the tips and techniques on how to crack the questions. So let's go ahead and quickly get started with our session. Okay, and in case you missed the physics live session yesterday, you can go back and see the recording on that. It's up on our channel, Manocha Academy. So there I've gone over the important physics questions focused on CBSE class 10. And also there's a useful video for you on how to write your exam to get good marks. So it's a short video of about 7-8 minutes. You can check that out. And we also have an important video on IUPAC naming of organic compounds. So these are all there on our channel. Hello, hi, thank you everyone for your support. It's really amazing. So thanks from the Manocha Academy team. Hi Vinay, hi Messi we have, and hi Atul, hi Prince Gautam. Hello everyone, hi Shobit Sahu, hi Varsha. Okay, so let's quickly get started. And once again guys, all the best for your exams. And I also have a website, manochaacademy.com. So do check it out. We have courses and lots of quizzes and questions there also for practice. So it's an additional resource for all of you. And we, of course, have our YouTube channel, Manocha Academy. And now we have over, I think, 122,000 subscribers. So once again, thanks a lot for your support. It's really awesome. Hi, Raji Pillai. Hi, Atul, hi Ramachandra, hi Mohammad Hussain, hello everyone, and let's go ahead and get started, right? Because I know a lot of you have your exam tomorrow. So here's the first question, and guys, keep your pen and paper ready and go ahead and give me the answers. So what's the first question? When food is kept outside for a long time, it tastes bad. This phenomena is known as A. Reduction, B. Rancidity, C. Corrosion, and D. Oxidation. So what do you think is the answer here? Excellent. I see a lot of people are answering rancidity is the correct answer. So it is the option number B. Because remember, this phenomena for food being kept outside, when it turns bad, it gets a bad taste, a bad smell, it's known as rancidity. And be careful, don't answer oxidation, because rancidity is a type of oxidation where the food gets oxidized and turns rancid. So here the best answer is, the phenomena is called rancidity and it's due to oxidation. So excellent. Let's move on to the next question. What is the name given to this reaction? Alcohol plus carboxylic acid gives ester plus water. So here are our options. A. Combination, B. Neutralization, C. Saponification, and D. Esterification. So guys, what do you think? I see some C's out there, some D's. There's an A also. So what is the answer? Actually, the answer is, the clue to the answer is in the question. Can you see an ester is formed? And remember, an ester is a sweet smelling compound, right? And it's formed by the reaction of alcohol and a carboxylic acid. So not just any acid, a carbon containing carboxylic acid, right? And so here good. So I do see some of you are getting the right answer, which is going to be D here. So the answer is esterification, because an ester is formed in this. And I think I can guarantee you a question will come tomorrow on esterification. So watch out for this. It's a very important reaction. You can go and revise it once more, right? And maybe we'll see some more questions on it also in this session. So remember, alcohol plus carboxylic acid gives you ester and water. Excellent. Let's move on to the next question. The pH of 3 solutions, A, B, and C, are 3, 4, and 6 respectively. Okay, so let's write that down. We have 3 solutions, A, B, and C, and their pH values are given to us. It's given as 3, 4, and 6. Now you need to arrange A, B, C in increasing order of acidic strength. So what do you think will be so you have to give the answer in terms of the letters A, B, C. So what do you think the answer is going to be here? So who's the most acidic? Remember on the pH scale. So when you have the pH scale goes from 0 to 14, right? And we know that the value 7 is neutral. Okay. So anything which is less than 7 and which is more closer to 0 is acidic. So as you go to lower values like 1, 2, that's more acidic than a value of 6. And for the base, it's opposite. As you go closer to the number 14, so if it's 13, then it's highly basic, right? So these values are basic in nature and these values are acidic in nature. So who's the most acidic here? Pretty simple. It's going to be A. A is the most acidic over here, right? Because it has the pH value of 3 and C is the least acidic. So what is the answer going to be? So be very careful in the exam. They've asked increasing order of acidic strength, right? So increasing order. So the last one should be the strongest. So the answer is going to be C, B, A. Is that right? Because C is the least acidic and A is the most acidic here. A has a pH of 3 and we want an increasing order, right? The acidity is increasing here. So an increasing order of acidic strength. So good. I see a lot of you. AB the gamer has got CBA. Even Rakesh. Excellent. So the answer here is going to be C, B, and A. Let's move on to the next question. So this question is, we have 2 reactions given in symbol form. AD plus C gives CD plus A. And CD plus B gives us BD plus C. So we need to arrange these in the ABC in the order of decreasing reactivity. Okay, so this is an interesting question. So if you look at the first reaction, let's write that down. AD plus C gives us CD plus A, right? That's our first reaction here. And so can you see what type of reaction is this? Correct, it's single displacement. Can you see that C is displacing A, right? Because C displaces A and you can see that A comes out. C combines with D. So we know from this reaction we can say that C is more reactive than A. Does that make sense? Because this is a single displacement reaction and students, you can see here that C is displacing A. And now if we write the next reaction where we have CD plus B gives BD plus C. Okay, so what's happening here? Can you see that B is displacing C here, right? Because can you see that C comes out and B is now in its position. So we can say that B is more reactive than C. Is that right? It's again a displacement reaction where B pushes off. It displaces C. So now if we combine these two, what do we get? B is more reactive than C and that's more reactive than A. But be careful, it says we want in the order of decreasing reactivity, right? Oh, okay, so this will be our answer, right? Because you want it in the order of decreasing reactivity. So read the question very carefully. That means you want the last one should be the least reactive. Okay, excellent. I see a lot of you have got the correct answer. B, C, A is perfectly the right answer here. Very good. Now let's go on to the next question. So great guys, you guys have done a good preparation for chemistry and try to answer this question. State the modern periodic law. This is a very simple question but very important. Often it comes in the exams. So here we need to write down the definition. So what does the modern periodic law state? It states that properties, so please write down the whole sentence in the exam, right? Properties of elements are a periodic function, okay, of their atomic number. Don't write atomic mass. It's the periodic function of their atomic number. Because remember, the modern periodic table or the modern periodic law is based on atomic number. Mendeleev's periodic table was based on atomic mass. Excellent. I see some answers. I can see International Gaming Tech. He has the right answer. Very good. Yeah, you can mention that they are arranged in the increasing order of atomic number, but we need to mention properties of elements. And they are a periodic. This is a very key word here because it's saying modern periodic law. So they're a periodic function of the atomic number, means the properties will periodically repeat if you arrange them in the atomic number. And you know that in the periodic table, when we arrange it in increasing order of atomic number, the properties keep repeating. So you can get this important question in your test. Okay, great. Let's go on to the next question. A green colored hydrated metallic salt on heating loses its water of crystallization and gives a suffocating smell. Identify the salt. So here we've been given some options: copper sulfate.5H2O, Na2CO3.10H2O, ferrous sulfate.7H2O, and calcium sulfate.2H2O. So which one do you think is the answer here? It says a green colored salt, so I'll use a green pen here. So what should be the answer? I see Avigna Daruka, he says C. Supraja also says C. I'm seeing a lot of C's here. Okay, so I'll take your answer. So let's start with that and let's see if we get it. So it is a ferrous sulfate dot 7H2O. And this is commonly known as green vitriol, right? Copper sulfate is, this guy is blue vitriol. So this is not a green colored salt. Okay. And so green vitriol, when you heat it, first thing we know that it loses its water of crystallization. So that's going to be the reaction. And friends, don't forget to balance the reaction tomorrow in the exam. You know, I remember in my chemistry exam, I'd walk in and keep saying to myself to balance the equation, because you don't want to leave the equations unbalanced. Okay, so we need to put in this 7. And now when ferrous sulfate, what will be the next step? Ferrous sulfate, when it's strongly heated, it will give us Fe2O3 plus sulfur dioxide, right? And sulfur trioxide. And is this equation balanced? No, check carefully. We need to balance it. Let's say I multiply this 2 iron there. So I'm going to multiply by 2. And I think that's going to balance the equation for us. So it's very easy to balance this one. And what is the cause of the suffocating smell? It's due to these sulfur oxides that are produced. So they cause the suffocating smell. And so the correct answer for this is ferrous sulfate dot 7H2O. So again, remember friends, don't forget to balance the reaction in the exam, right? Excellent. You guys are doing great. Let's go on to the next question. Which substance is not produced in the chlor-alkali process? And here are your options: A, NaCl, B, NaOH, C, hydrogen, and D, chlorine. So what do you think is the answer here? Okay. So which substance, carefully read the question, okay, in the exam, especially the multiple choice, which substance is not produced, okay? So first, what is the chlor-alkali process? Do you remember the reaction? So I see people are writing NaCl. Someone's a little confused about the question. So which substance is not produced means it is not in the products, okay? So what is the important chlor-alkali process reaction? So in these kind of questions, I'll just erase that. In these kind of questions, first think about the reaction, okay? Don't jump to the answer. So the chlor-alkali process, you know, involves brine, which is basically an aqueous solution of sodium chloride. And when you do electrolysis of that, so when you pass electric current, okay, what are the products? NaOH plus hydrogen plus chlorine. Okay, so those are the products of the chlor-alkali process. And again, we should balance our equation. So 2, and that's going to be 2 here, and we need another 2 here. Okay, so this is our, and now if you look at it, why is it called chlor-alkali process? Because you can see chlorine and an alkali are produced here. So this process is known as a chlor-alkali process because it produces chlorine and alkali. Hydrogen is not in the name, okay? So which substance is not produced? So the correct answer here is going to be, it's NaCl, right? Because NaCl is in the reactant, it's not the product. So the correct answer here, excellent. I see Ganesh has got A. Some of you, Nilesh also got the correct answer A. So read the question carefully. Now let's move on to the next question. Great. The next question says, what is the electrolyte used in the electrorefining of copper? So is it A, copper, B, graphite, C, ferrous sulfate, or D, copper sulfate? So what is the electrolyte used here? What do you think? So I see a lot of people are writing D. I see some C's also, okay? Because remember in the electrorefining of copper sulfate, right? So you have an electrolyte and then you have the cathode and then the impure anode, remember? So which is the copper block, okay? So you have the cathode and, right? So this is our setup here. And they're asking what is the electrolyte? Means what is the solution here? So this is called the electrolyte because in the electrolysis, the solution is known as electrolyte. So which electrolyte is used in this? So I see a lot of D's. Joshi has written D. Meghna Soni also D. That's right, because we are doing electrorefining of copper. So you don't want to put ferrous sulfate in there because you don't want iron to interfere. So you can guess this answer, and copper is used as the, so the first one is used as the cathode and anode, the pure cathode and the impure anode, right? So that's not the answer, and graphite is used in some electrolysis process as the electrode. So here the best answer is copper sulfate, right? Because we use D. Excellent. Ajay has also got the correct answer. Supraja, very good. So that's how you solve this question, right? So look at all your options carefully, especially in multiple choice, right? Let's move on to the next question here. So what does our next question say? Metals do not liberate hydrogen gas when treated with nitric acid because nitric acid is A, weak acid, B, strong acid, C, strong oxidizing agent, D, strong reducing agent. Okay, so what do you think here? So this one is also, it's a little tricky question because we know that normally when you react a metal, right? So when you react a metal with a dilute acid, so what is the normal reaction? It's zinc chloride plus hydrogen, right? And again, don't forget to balance the equation. But when the same metal is reacted with nitric acid, okay, hydrogen is not produced. So usually hydrogen gas is liberated, but not with nitric acid. And here, so how do we work out this answer? We know nitric acid is a strong acid, so it cannot be weak, it cannot be A. But the important thing here is nitric acid acts as a, so good, I see a lot of people are giving the right answer as C. It's a strong oxidizing agent. So nitric acid is actually going to produce nitrogen oxides. So I think most of you don't have the reaction in your syllabus. So I'll not confuse you before the exam with writing the reaction. So it's nitrogen oxides and you'll get water and zinc nitrate, right? So here, the main key point to remember is nitric acid is an exceptional acid, unlike HCl or H2SO4 in dilute form, which are used, because it is a strong oxidizing agent. So very good. A lot of you have got the right answer, which is C. Let's quickly move on to the next question. Give the reaction to prepare ethyl acetate. Give a name for this reaction. Okay. So here first you need to think, what compound are they asking about? Ethyl acetate, right? So ethyl acetate here, what is the formula of ethyl? So ethyl acetate is the common name, right? It's not the IUPAC name. So you can think of what will be the IUPAC name of ethyl acetate. It's going to be, so basically ethyl acetate is essentially ethyl ethanoate. Okay. So which compound are we talking about here? We are talking about an ester. Okay. Remember, this is the main ester that you have in your syllabus, right? You can also produce any type of ester with the esterification reaction, but usually the ethyl ethanoate is most commonly asked. Okay. And so what is the formula of the ester? First think of the formula. So you know the acetate ion is CH3COO and the ethyl part comes this side, right? So the compound we are talking about is ethyl acetate. And how do we get an ester? Very simple. We just saw that in this quiz, that you react an alcohol with a carboxylic acid. Okay. And that's going to produce ester and water. And so let me show you a trick of how to easily work out this reaction. So very good. I see some of you are writing CH3CO, C2H5. That's the right formula. So let me show you a very simple trick of how to work out the alcohol and the acid. So you just need to cut this compound. It's like cutting a cake, right? So break this compound into its acetate part. And these are all rough stuff, you know, so just do it in pencil. Don't leave all this in the exam, like I mentioned in my video on organic reactions. So here, this is the acid part, you know, right? That CH3CO, because it comes from acetic acid. Because if you just had an H there, it would be the acetic acid. So this part will be the acid part. Okay. And C2H5, ethyl is going to come from, so that is going to come from the alcohol. Okay. So very simple. What we did is we got this acetate part from the acid and the C2H5 from the alcohol. And so then it's very simple. Of course, H and OH will combine to give water. So let me just show you the plus minus here. And this, you know, is H plus ion it releases and this is minus. So now can you see that if you combine these two, you get water, and you just need to combine these two. But when you're combining these two, be careful. We need to write the acetate part first. So the acid part comes first, and then you write the ethyl part. So just remember that when you're forming the ester, the acid part, look here, the CH3COO part comes first, and then the alcohol part. Even though the name is ethyl ethanoate, the ethanoate part comes first, then ethyl. Okay. And what is the name for this reaction, guys? Okay. Very good. I see some of you have got. So what do we need? We need ethanol or ethyl alcohol and ethanoic acid. Ethanol is the IUPAC name. Ethanoic acid again is the IUPAC name, and the ester formed is ethyl ethanoate. And what is the name for this reaction? Again, the famous one. Very good. I see some of you are getting the correct answer. It's going to be, the reaction is esterification. Okay. So the name for this reaction is, it's esterification. Excellent. All right, great. Let's move on to the next question here. So what is the next question? What process is used in the extraction of a metal from its sulphide ore. So is it calcination, roasting, heating, or electrolysis? What is the correct answer there? So what do you think is going to be the answer here? Oops, sorry. What process is used in the extraction of a metal from its sulphide ore? Is it calcination, roasting, heating, or electrolysis? Okay. So I see some people are writing roasting, some are thinking it's A, calcination. So let me teach you a simple trick to remember this one. So the trick is that calcination is used for the carbonate ores. Okay. So the easy way to remember is C for calcination, C for carbonate ores. So you can remember that in your exam, that calcination for carbonate ores and roasting is used for the sulphide ores. Okay. These two are very important processes, right? And remember what was roasting? So in roasting, let's say you have zinc sulphide, you need to heat in the presence of air. Okay. And what are you going to get? It's going to be zinc oxide plus sulfur dioxide. Okay. And again, don't forget to balance the reaction. So we have, we can balance this zinc and sulfur. So to balance it, this is going to be 3 by 2. I'll use the fraction trick and we can just multiply this throughout by 2 to get it balanced, right? So here the correct answer is going to be B, roasting. It's not by heating and you don't need electrolysis here. In carbonates, it's heating of the carbonate ore in the absence of air. Okay, so excellent. I see Ajay, Pushpak, they've all got roasting. AB the gamer, very good. Okay, and so that's the right answer. Excellent. Let's move on to the next question. Sorry, I can't take everyone's name here because it's scrolling really fast. Let's go to the next question. In the reaction below, which substance is being reduced? And the reaction is MnO2 plus 4HCl gives MnCl2 plus water plus chlorine. So what do you think is the answer here? So this is an important question where you need to look at what is being oxidized or what is being reduced. And let me show you the trick of how to do this one. So let's write down the reaction. Okay. So all of you think what will be the answer here while I'm writing down the reaction. So you can see that the trick of solving this is, first thing, MnO2 is turning into MnCl2, right? And HCl is turning into chlorine here. Okay, can you see that? So here MnO2 loses oxygen and becomes MnCl2, right? So can you see that MnO2 is losing oxygen and becoming MnCl2? So what is happening here? So I can see different answers here. A, C, some of you are saying. So what will it be? That since MnO2 is losing oxygen, it is being reduced. And HCl is losing hydrogen, right, to become chlorine. So losing hydrogen means it is getting oxidized. And always when they ask you who's oxidized, who's reduced, it's always the reactants, never the products. Okay. Same if they ask you who's the oxidizing agent, who's the reducing agent. So remember this important tip, it's always the reactants, not the products. Okay. What is it being reduced to is a different question. Okay. So here our answer is going to be who's being reduced? MnO2. So the correct answer here is A. Excellent. I see Vishal, Zahir, a lot of you, Ajay, Srinivas, they've got the correct answer, MnO2. Excellent. A. I see a lot of you are getting the answer. Very good. Let's go on to the next question. How is bleaching powder prepared? Okay. So here basically you need to know the reaction of how to prepare bleaching powder. So what is the formula of bleaching powder first of all? So bleaching powder has the formula CaOCl2, right? I remember that as CaOCl2, okay? CaOCl2, okay? So here we are not asking about, I see some of you are writing chlor-alkali. That's not the goal here. We need to give the reaction of preparing bleaching powder. So it's going to be, you take slaked lime or calcium hydroxide and you pass chlorine through it. And then you know the reaction, you're going to get bleaching powder, which is calcium oxychloride, and I remember it as CaCl2. That's how I remember the formula. Okay, so you can learn it easily that way. CaCl2, CaOCl2, and you can see that is the reaction over here. Okay, and please check, is the reaction balanced? I think it looks balanced. So again, balance the reactions tomorrow. Don't leave them unbalanced. Excellent. I see Needu has got the right answer there. Hansi also, very good. Excellent. And just take care and make sure you're writing Cl2, not Cl, right? Write down the right formula in the reactions. Very good. Let's go to the next question. The molecular weight of an alkyne is 54U. Name the alkyne and draw its structural formula. Okay, so this is an interesting question. And again, I'm going a bit fast today, you know, because a lot of you have your science exam tomorrow. So all the best. And if you're finding this session useful, please hit the like button and share it with your friends. Okay, so let's take a look at this question. So it says the molecular weight is given as 54U. Okay, and what is the general formula for an alkyne? You know the general formula is CnH2n minus 2. So that's for an alkyne. So what is the trick to solving this one? So what you need to do here is just use N in the equation. So what is the mass of carbon? It's 12. So 12 times N plus hydrogen has a mass of 1, right? Atomic mass of 1. So 2N minus 2 of those, right? So these add up to give you 54, right? So let's go ahead and solve that. So if we solve it, we'll get 14N equals 56. So what does N work out to be? 56 by 14. So N is 4. Okay, so you can easily solve using this simple equation and base. So what is the key concept here that you need to remember? The general formula of alkyne. Remember, alkanes are CnH2n plus 2. Alkene is again 2 less, so CnH2n, and alkyne is CnH2n minus 2, right? And so what will the compound be? It's basically going to be C4 and 2 into 4, 8 minus 2. So C4H6. Okay. So what is the name of this alkyne? So what do you think, guys, the name of this alkyne is? Right. So this alkyne has 4 carbon in it. So it's going to be called butane. Right. The name of this alkyne is butane. Excellent. And draw its structural formula. Remember to do this in the exam, you know, don't leave out any part. So the structural formula of butane is going to be, so you draw the 4 carbons, okay, and you need to draw a triple bond. A lot of times people ask that should I draw it at the first position, second, third, where? Draw it at the first. If nothing is given, you know it's butane, just consider it to be at the first position. And now carefully fill in the hydrogen, guys, okay. So the first carbon has 3 bonds. So it will get 1 hydrogen there. Okay. So that's going to be 1 hydrogen. Do I need to put any hydrogen in the second carbon? No, because you can see 1, 2, 3, 4 bonds are already filled. And this carbon has 2 bonds filled. So there's going to be 2 more hydrogens here, right? And the last carbon will have 3 hydrogens. Okay. So you can see 1, 2, 3, 4, 5, 6 hydrogens. And the answer is C4H6. Okay. Excellent. Let's go ahead and do that. I know some of you are asking how to draw in the live streaming. As I told you in the beginning, please sit with a pen and paper and practice this for your test, right? I know you can't draw it in the chat. So some of the questions will be doing on paper, right? For your practice. Let's go to this question. An element X is in group 2 of the periodic table and an element Y is in group 17. If X and Y combine, what is the chemical formula and the type of bond formed between X and Y? So this is a really important question. Usually this type of question comes in the tests, right? Where you need to think about the periodic table. And note, we've not been given the elements, so don't try to identify them. You've just been given the information that X is in group 2. So we'll write that, okay? and Y is in group 17. Now if X and Y combine, so combine means we need to use their valency, right? Okay, so what is X's valency going to be? Since it's in group 2, so please write that down. So show the working in the test. Its valency is 2. And the valency of Y is going to be, because it's in group 2 and Y is in group 17, so its valency is going to be 1. Is that right? Okay, great. I see a lot of you are writing XY2 in the chat. I can see Himesh has written. Excellent. So now you just basically have to do the crisscross in valency, right? So X has a valency of 2, Y has a valency of 1. And if you do the crisscross, we get the final answer as XY2. Right? So that is the correct answer here. And what is the type of bond? So here you need to be James Bond and tell which type of bond is formed. And what is the simple rule to remember? Metal and non-metal form an ionic or electrovalent bond, right? So we call it an ionic bond is formed between a metal and non-metal, and a non-metal and non-metal form a covalent bond. So here we know that since it's in group 2, so this guy is basically a metal, X is a metal here, and Y is a non-metal, right? Because it's in group 17, it's in the halogen group, and that one is in the alkaline earth metals. So it's between a metal and non-metal. So the correct answer here will be the type of bond is ionic. Excellent. I see most of you have got the right answer there. So this is an ionic bond. Somebody is asking what's an ionic bond? Formed due to transfer of electron, right? Covalent bond due to sharing of electrons. Excellent. Let's go to the next question. What reaction is used to convert vegetable oil to fat? So this is a simple one, right? Remember, vegetable oil is an unsaturated compound, right? So it's represented like this usually, where R represents the carbon chain. And we want to convert that into a fat. And you know that fat is a saturated compound, right? So what is the trick here? So fat has this thing. And how do you saturate it? By adding hydrogen to it. Okay. So this is an addition reaction, and it's specially called hydrogenation because, very good, I see Ayesha Begum, they have the right answer. Brajraj Singh, right? Very good, because hydrogen is being added. So hydrogen is added in the presence of nickel catalyst usually. And so this answer is going to be hydrogenation. Excellent. Let's go on to the next question. Which one is more reactive, sodium or potassium, and why? So this is an important question where since they're asking you the reason, you can't simply say because it's higher up in the reactivity series, right? You need to explain here why the element is more reactive. And why do we need to explain that? Because we know both these elements are in group 1, right? So you have sodium and potassium both in group 1. Okay, so which one do you think is going to be more reactive? So here you need to think about the electron configuration. So sodium has the electron configuration 2, 8, 1. And potassium has, right? Because it's in the 4th period. So because of the atomic number is 11 and this guy is 19, right? So that's the electron configuration. Now which one is more reactive? Because you can see that potassium has 4 shells, okay? And sodium has 3 shells. So who do you think is going to find it easier to lose that valence electron? Both of them have 1 valence electron. Now, since potassium has more shells, it's further away from the nucleus. Okay, so the nuclear pull on the valence electron for potassium is going to be lesser than sodium. So potassium will find it easy to lose the valence electron because it has more shells, the nuclear pull is less, and so the correct answer is potassium is more reactive. And so this is basically a periodic table question, not a metallurgy question where you can't just say that, okay, it's higher in the reactivity series, because we need to explain why. And we explain it based on the periodic table concept on the nuclear pull and the number of shells. Very good. I see most of you are writing potassium. That's the right answer. Let's look at the next interesting question. Propanone and propanal are isomers. The statement, is it true or false? What do you think? So propanone and propanal are isomers. So first let's quickly draw this. Let me go ahead and draw propanone here. So it's going to be this ketone, right? So this is our guy propanone. Okay, and let's go ahead and draw propanal also. So propanal is going to be CH3, CH2, CHO, right? Okay, so that is it's an aldehyde. So this guy is a ketone, this guy an aldehyde. Are they isomers? So what is the definition of isomers? Remember, they have the same molecular formula but different structure. So let's take a look at what is the molecular formula of this. So I've drawn the structures here. The structures are clearly different. The first one is a ketone, propanone, and propanal is an aldehyde. So here the molecular formula is going to be pretty simple. You count the carbon C3H6O. And what about propanal's molecular formula? 3 carbons, so C3. How many hydrogens are there? 3 plus 2 plus 1. So that's again H6 and again 1 oxygen. So can you see that both of them have exactly the same formula, C3H6O. So these guys are definitely isomers. A is the right answer. Excellent, true. Okay, so let's quickly go to the next question. Give an example of a pair of misfit in Mendeleev's periodic table. Okay, so remember Mendeleev had to make some exceptions in his periodic table. Okay, and what was the misfit there? So what was the key exception or the important example that we have of the exception? Remember, it was cobalt and nickel, right? Cobalt and nickel are the two important elements, right? And so do you remember that the atomic number of cobalt is 27 and 28? So they are in the right order in the modern periodic table, but in the Mendeleev's periodic table, do you know what is the exception? Right? So in Mendeleev's periodic table, we know that cobalt had a higher atomic mass as compared to nickel, but it's still, so I think the values were something like 58.9 and 58.7. You can double check that, but basically the concept is cobalt has a higher atomic mass. So actually cobalt should come after nickel because Mendeleev arranged them in the increasing order of atomic masses, right? And so this was an exception he had to make so that the elements have similar chemical properties in their groups. So he had to switch the position. But in the modern periodic table, it is fixed. And there's another example for that also, tellurium and iodine. But the most famous one, if they ask you in the exam, write cobalt and nickel. Okay. Very good. Let's go to the next question quickly. This is an easy one, I think. Copper on corrosion forms A, rust, B, basic copper carbonate, C, copper sulphide, or D, copper oxide. What do you think is the answer here? Okay, so copper, some of you are thinking rust. No, iron rust, right? Copper, we don't say it forms rust because rust is Fe2O3. So here, I think this one is given in your NCERT textbook, right? That copper forms basic copper carbonate. So what is the formula of that? It's basically copper carbonate dot copper hydroxide. Okay, so the correct answer is, let me write that again here, since I think you can't see it clearly, copper carbonate dot copper hydroxide. Okay. And it's called basic copper carbonate. Why? Because this is the copper carbonate and you know that copper hydroxide is basic in nature. So just remember that copper doesn't form rust, it doesn't form sulphide or oxide, it forms basic carbonate, copper carbonate, and this has a greenish color. Okay, so that's why it has a greenish tinge to it. Okay, excellent. Let's go on to the next question. Yes, I see a lot of you have got the correct answer B. What is the nature of ammonium nitrate solution? So is it acidic, basic, neutral, or none of these? Okay, so the important concept in this question is, so when you look at ammonium nitrate here, so this is not very difficult if you can just remember this simple concept that ammonium nitrate is a salt, and when you're taking a solution, obviously you're mixing water. Okay, so how do you work it out? Normally we do acid plus base is salt plus water, but this one is the opposite, right? Salt plus water is going to give you an acid or a base, acid and base, right? And this topic is known as hydrolysis of salts. Okay, so this is hydrolysis of salt. Simple. You are adding salt and water. So what do we get here? So if you do this reaction, we are going to get, it's going to be ammonium hydroxide and nitric acid. So you can see that this ammonium part will give you the ammonium hydroxide and the nitrate will go into the hydrogen. Okay, so we have ammonium hydroxide and nitric acid. Okay, I see A, B, D is the answer. So here, how do you solve this? Ammonium hydroxide is a weak base. Remember that? The strong bases in our syllabus are sodium hydroxide, potassium hydroxide. Ammonium hydroxide is a weak base. And nitric acid, I think all of you know, is a strong acid. So what is this solution going to be in nature? Because you have a strong acid and a weak base. So the net effect is the solution is going to be the right answer. I think Hansi's got the right answer. Hariharan, very good. A. Vishnu, excellent. Ajay. So the correct answer is going to be A, acidic. But note the trick here. It's okay if you got it wrong, doesn't matter. What is the trick of this question? That you do salt plus water and then you are going to get a base and an acid. Okay, so it's the opposite of neutralization. Neutralization is acid plus base gives salt plus water. Here you do the opposite and then analyze the products. Here we have a weak base and a strong acid. So it's going to be acidic in nature. Excellent. Let's move on to the next question. Okay, this is an IUPAC name, right? So come on, I want you guys to try this, right? What is the IUPAC name of this compound? So go ahead and try it out. Remember, what are the tips in the IUPAC naming? That you need to consider the longest carbon chain. And as I taught in that video, you know, on IUPAC naming, number it forward and backward, consider the smallest numbers and write your answer. So what will be the name of this compound, right? So an easy way to do this is if there was no chlorine, right? So if this compound was very simple, if it just had hydrogen, its name would have been ethane. So if nothing was there, but you can see that there are two chlorines in here, right? So otherwise the name would have been ethane. So this is not exactly a ethane, right? So it's going to be, we need to add it in the prefix. So the name of this compound is going to be, there are two chlorines in there. So good. It's going to be a dichloroethane. But there's one more small detail, right? So again, as I said, identify the longest carbon chain. So you can see there's a 2 carbon chain here. So there are 2 carbons. So let's number them 1, 2, 1, 2, forward, backward. Okay. And so you have chlorine in which positions? So we can't just simply end it at dichloroethane because we need to give the positions of chlorine also. So it's going to be 1, 2 dichloroethane. Let me write that clearly again. 1, 2 dichloroethane. Okay, guys. And what is the important thing you can remember? Between two numbers, always put a comma. So can you see the comma here? Between two numbers and between a number and a letter. Okay. So between a number and a letter, you put the dash. Can you see that dash? So we need to give 1, 2. So I can see a lot of you are getting the right answer, but some of you are forgetting the dash. Some of you are forgetting the comma. Okay. Or some of you have written dichloroethane. It's okay. Just remember that you need to mention the position also. So 1, 2 dichloroethane is the correct answer. Fantastic. Let's go to the next question. Glucose and alcohol both contain hydrogen. Why don't they show acidic properties? Okay. So here, even if you don't know the answer, the trick is in the exam, usually you can work out or guess this answer. So my suggestion would be don't leave any answer blank. Usually there's no negative marking. So you guys don't have negative marking. So attempt every question, right? Even if it's your best guess. So make a smart guess. So here, what do you think is going to be the answer? Because that glucose and alcohol, both these compounds have hydrogen in them, right? But why don't they show acidic properties? Okay, because what is the key thing about an acid? You know, it releases H3O plus. Remember that guy? The hydronium ion. Okay, so an acid always releases hydronium ion. So basically you need to write in this answer that these compounds, when dissolved in water, they don't release hydronium ion. They don't ionize and they don't release the hydronium ion. So you just shouldn't mention only ion. You need to mention the H3O plus or hydronium ion, because if that's not there, the acidic properties will not be there. So very good. I see some of you are getting that right answer. So again, as I said, this answer can be sort of worked out. You can guess it. So don't leave any answer blank in your test. Okay. Let's go on to the next question. Show the formation of the bond in magnesium chloride. So yes, these can be those questions where you get to draw the bond, right? So again, you need to be a James Bond here. You need to decide whether is it a ionic bond or a covalent bond. So first ask yourself the question before rushing into the answer, is this magnesium chloride an ionic bond or a covalent? And let's see if we can apply our concept. What did I explain today in the session? That magnesium is a metal and chlorine we know is a non-metal. Okay. So metal and a non-metal, they form what type of bond? They form an ionic bond, right? So metal and non-metal produce a ionic bond. Non-metal produce a covalent bond. Okay. So metal, non-metal, ionic, non-metal, non-metal, covalent. Okay. Metals form alloys, right? So we don't care about metal-metal bonding. So here, how do you draw this diagram? So let's go ahead and draw magnesium. Okay. So magnesium, and we need to show the electrons in the valence shell, right? So let me go ahead and draw the electrons for magnesium. So let's say these are the 2 electrons, and we know that the compound's formula is MgCl2, right? So the formula is MgCl2. So we need 2 chlorines here. So let's draw that. And chlorine has 7 valence electrons. Magnesium has 2. I've shown that already. And chlorine, you know, is in group 17 with 7 valence electrons. And now, since it's an ionic bond, we need to show the transfer of the electrons, right? So guys, practice this diagram in your notebooks, right? Yeah, I know you can't draw this in live streaming, but it's an important question, so I didn't want to leave this one out, okay? And so how you can draw it in pen and paper. And so then what do you need to mention here? Since magnesium has lost the 2 electrons, it's going to be Mg2 plus. And chlorine has gained an electron, right? So it's going to be Cl minus. And there are 2 of them, okay? And you need to, so actually I didn't show the intermediate step. So it's better to show that as well. So before you, let me erase this. So before you show the final answer, what you can show here is magnesium loses the 2 electrons, right? Or we can draw it here itself. So since magnesium has lost the 2 electrons, let's go ahead and draw these, and this electron is going to come in here, right? Okay. And this is the chlorine minus. Let's pull out the minus so that it's not confusing. And this is going to be your answer, right? So magnesium loses the 2 electrons, and this is what it becomes, and this is MgCl2. So this is an ionic bond. Remember to think about ionic or covalent, then you draw the diagram, because covalent is sharing, ionic is transfer of electron. Okay. So we don't have too many questions left. So let's finish this off. So what is the IUPAC name of this compound? Another IUPAC naming. Do you guys want to try this? Okay. So again, first look at the longest carbon chain here. So what is our longest carbon chain? We have 3 carbons. Okay. And let's number them forward and backwards. Okay. So we have a 3 carbon chain here. And we are going to number this forward and backward here. So basically the compound would, if nothing else was there, it would have been a propane, because we have carbon and single bonds. But you can see that there's an OH in there, and there is also a Br in here. Okay. So what is the name going to be? So there's going to be it's OH is an alcohol, and there's the halide group also. Okay. And here one important thing is who gets priority. Is it alcohol or the halides? So important thing is alcohol gets higher priority than halogens. What does it mean higher priority? That means the lower, this numbering is going to be considered, okay? So because he says, I want position number 1. So position number 1 goes to alcohol and position number 3 goes to bromine. Excellent. I see some of you are getting the right answer, but I see sometimes you're missing the dash out there. So be careful in the final answer what you're writing. So the basic name is a propanol, right? Because it's at position 1. So we don't need to write 1 propanol. And then there's a bromine in there. So bromo. And you know the alcohol name goes in the suffix. So propane plus all, and you remove that E, so it's propanol, and the bromo is in front. And what is the position of the bromine? Don't forget to mention the position, 3-bromo propanol. Very good. Some of you have written bromo propanol, but it's 3-bromo because bromo does not get position number 1. Can you see here? So this numbering doesn't count. So let me erase the numbering on top if that's confusing you, because the numbering at the bottom counts. Why? Because alcohol OH group gets higher priority, so it gets position number 1, and bromine gets position number 3. So the correct answer here is 3-bromo propanol. So it's 3-bromo 1 propanol or propan 1-ol, but we don't need to mention the 1. Excellent. I see a lot of you have got that right answer. So remember this important question, and you can solve many using this concept. Okay. Write the IUPAC name and the structural formula of the next homologue of acetic acid. Okay. So what is the formula of acetic acid first of all? So we know acetic acid is ethanoic acid, right? So it's CH3COH. So this is ethanoic acid, right? Very good. And now we ask the next homologue. Okay. So remember in a homologous series, CH2 gets added each time, right? So in the homologous series, you add a CH2. 1 carbon, 2 hydrogen gets added every time. So to this guy, we need to add CH2. So what does our compound become? So we are going to get the compound CH3, CH2, COOH. So the name is pretty simple. 3 carbon, it's a carboxylic acid. So the name is going to be propanoic acid, right? Because we asked the next homologue. This guy is ethanoic acid. We've been asked who's the next acid after it. Propanoic acid, correct? And draw its structure. So whenever they ask you to draw the structural formula, make sure you draw the whole thing, right? So basically you need to show all the bonds and this one, right? And show all the hydrogens in there, right? So that is the full formula of structural formula of propanoic acid. This is the condensed formula, and this is our correct answer, the full structural formula. Okay. I think someone wants me to repeat. So if you can see this question, the IUPAC name, the question was the next homologue of acetic acid. So we know acetic acid is ethanoic acid. The next homologue is CH2 is going to be added, right? Because in the homologous series, we add 1 carbon, 2 hydrogen. So what is the next acid going to be? Propanoic acid. And so this is our answer, right? Okay, excellent. And now let's go on to and this is our last question for today. Okay, so we are coming to the end of the session, that how do you convert ethyl alcohol to acetic acid? Okay, so how do you do that? So again, ethyl alcohol, so that's the common name. So what is the IUPAC name? Ethanol. So we've been given C2H5OH. So first write that down, okay? And we need to convert that, okay? So that needs to be converted to ethanoic acid, acetic acid. So guys, how do you do that? Okay. So how do you convert ethanol to ethanoic acid? So here you need to use a strong oxidizing agent, right? So basically we need to give it nascent oxygen, and the strong oxidizing agent is alkaline KMNO4 or acidified potassium dichromate, right? So either alkaline potassium permanganate or acidified potassium dichromate. And you know that when you do that, it gets oxidized to the acid, and plus you're going to get water. So if you balance this reaction, this is going to be our answer. Very good. Using a strong oxidizing agent. So, and also it's mentioned in the book that you need to heat it, right? So always mention all the conditions for the organic reactions. So we are going to use an alkaline KMNO4 or an acidified potassium dichromate. I see some of you are having some doubts in the chat. So I would suggest, because it's not possible to answer each one's doubt, so you can, once the live session is over, you can leave your doubts in the comments and I'll respond to them as soon as possible. Okay, so if you have any specific doubts. And so in this question, it's basically doing strong, using a strong oxidizing agent, you do oxidation. Okay. And that brings us to the end of this session. So thanks a lot, all of you, for watching, and wishing you all the very best for your exams. And if you like this video, this live session, do hit the like button, and please, share it out with your friends. If you found it useful, please do share it out. And if you haven't subscribed to my channel, do consider subscribing. Hit the subscribe button right now and click on the notification bell. Really, all the very best for your exams. I know a lot of you have your exam tomorrow. Go with confidence. Go and give it your best. Read the question carefully. We learned a lot of important tips and techniques in this session. I hope you found it useful. And thanks a lot. Yeah, all the best. And I'm going to sign off here. So thank you for attending. And also do take a look at our website. It's manochaacademy.com, where you'll get more courses and questions and quizzes for your practice. So guys, wishing you all the very best. Go give it your best shot. I'm sure all of you will do well in the exam. Thank you for attending. Thanks a lot. Okay, thank you. Bye.